it looks as if we're stabilizing. Just to give the graduate students a little bit of a heads up, this is mostly about hearing from the faculty, but I would like you to just put your virtual hand up on the screen because when I'm finished speaking for a little bit here, I'd like to call on each one of you to just say what year you were in, a little bit about yourself, maybe what you're working on, where you just came from. It doesn't have to be terribly long. The purpose of this icebreaker is, in fact, for the graduate students to meet each other, for the graduate students to meet the staff and faculty, and learn about the things that we do. So this is primarily focused on understanding what the faculty do. Our other big event of this type is called the Bourne Symposium, which this year we'll have in the spring, close to the end of the semester. And that's where the graduate students and faculty who want to can provide presentations. Those presentations are American Geophysical Union style, typically about 10 minutes, followed by 2 minutes of questions and answers. The quality has been remarkable every single year. It's really been exciting to watch this. And all the graduate students will also have to do a short mini paper. It's a one-page paper. You can use it as gray literature in your resume. And it's about your research, obviously. So by the end of next semester, even if you're a first-year student, you can talk about the things that you think you might be doing, anything that you want. So I don't see any hands coming up. If you would, again, if you're a graduate student, this sounds like that commercial for Southern New Hampshire University. If you're a graduate student, put your virtual hand up, please. Virtual hand, so that because what I'm going to do is go through your virtual hands and I'll call on you. And then when we've gone through all the graduate students, if you are a staff member, if you would put your virtual hand up, and then after that, I'll turn the meeting over in terms of telling each one of us in the faculty who goes next. I'll turn it over to Becky, if that's okay, Becky, and because you have the list and she's put together an order for us. So we have 56 people. There are 135 in the Institute. That's pretty good. Some of them are obviously aren't able to join this sort of thing. I know we have a few people who will pop in and out, but this is a great showing. I'm sorry that for the second year in a row, we have not been able to all get together for dinner at the Orono Country Club. It was always a fun event, but nevertheless, it is as it is. This has been an interesting year for sure. Hopefully it'll be less interesting than last year, but we'll see. And things obviously went well for the Institute. We're really happy to see all of you here. So let me go through, I'm doing this based on the way I see it on the screen. So just give us a short description of who you are or anything you'd like. Liam Daniels, you're first up on my screen.
Hi, I'm Liam Daniels. I'm a first-year graduate student with the Climate Change Institute. I'm working under Dr. Bonnie Newsome. My background's in archaeology, and I'm going to be focusing on residue analysis, and I'm happy to be here.
Perfect. Alessandro.
I'm a PhD candidate. I'm from Italy, and I work in Jacqueline's Gill lab to investigate the legacy of the extinction of Pleistocene megafauna on the Beringia environment. And right now I'm working on some coprolites from Siberia.
Perfect. Thank you. Mark.
Hi, my name is Mark Royer. I'm a computer scientist that works with CHA. And most of my work's been with the P301 system here. I've done some other things with Andre. And most recently, I've been doing some data mining with the School of Marine Sciences. Thank you.
Thank you. Elizabeth.
Hi, my name is Elizabeth. I am a third-year master's student and also starting my first year as an interdisciplinary PhD student. I work with Dan Sandwice and study human relationships with the water environment and how those change during periods of rapid change in the ENSO system in Peru.
Great. Meredith.
Hi, I'm Meredith. I'm a second-year master's student in the School of Earth and Climate Sciences, and I'm working with Andrei Kerbotov on cryptotephra and polar ice cores.
Michaela.
Hi, I'm Kaylee. I'm a first-year master's student in CCI working with Seth, and I'm studying the spatial and temporal variability of fern thickness across the Juneau ice field.
Thank you. Kate.
Hi, I'm Kate Follansby. I'm a first-year master's student in the School of Economics. I'm on the Arctic Sauna NRT, and I'm working with Dr. Bell on sustainable development and tourism in Greenland.
When you're finished, if you would take your hand down so I don't get confused and call on you twice. Thank you. Scott.
Hello all, Scott Braddock. I work with Seth Campbell and Brenda Hall on changes in the West Arctic ice sheet. I'm going into my 4th year of my PhD right now.
Great. Sydney.
Hi, I'm Sydney. I'm a first-year master's student in the School of Earth and Climate Sciences, and I'm studying sea and ice interactions with Kristen Shield in South Greenland.
Thank you. Frankie.
Hi, everyone. My name is Frankie Saint-Amand, and I'm an interdisciplinary PhD candidate and a CCI student. I'm studying with Dan Sandwice and Alice Kelly, and I research El Nino Southern Oscillation on the north coast of Peru using mollusk bivalve, oxygen, and carbon isotopes.
Thank you. Lizzie.
Hi, everyone. I'm Lizzie Kadrani, second-year student, PhD student in Earth and Climate Science. So my supervisors are Paul Majersky and Andrei Kerbotov, and I study paleoclimate reconstruction, and I'm working on analyzing ice cores from Malone Hills, Blue Ice Area, Antarctica.
Thank you. Aaron.
Hi, my name's Aaron Chessler. I'm a this is my 5th in a few months year of my PhD. Trying to wrap up pretty soon. I'm studying the South Pole ice core, dust, and geochemical records.
Thank you. Nicholas.
Hi, Nick Whiteman, PhD student of Peter Coons, working on multi-scale fluid dynamics problems of coast and COVID. So 1 foot on each side.
Great. Heather Landazuri, since we have more than one Heather.
Hi, so I'm Heather Landazuri. I'm a 3rd-year master's student in CCI and anthropology. Dan Sandwice is my advisor. I'm also being advised by Kirk Mush. I am your EID rep and research assistant, and I'm also your GSG rep, so put a face to the name. And I'm studying ENSO and how it relates to avifaunal consumption on the coast of Peru through prehistory.
Thank you. Thank you. Heather Clifford.
Hi, Heather Clifford. I'm a 3rd-year PhD student or PhD candidate. I work with Paul Majersky and Andrei Kerbotov, and I study ice cores in high mountain regions, and also in CCI in the Earth and Climate Sciences department.
Thank you. Mario.
Hi, I'm Mariusz Potocki. I'm from Poland. I am PhD candidate working with Paul Majersky. My research focus on ice cores from Antarctic Peninsula region, Andes, and Himalayas. Thank you.
Thank you. Holly.
Hi, I'm Holly. I'm a 1st-year PhD student at Maine, working with Kate Ruskin. I have a background in geoscience education, and I'm currently doing science education research with Kate, and we're looking at the outcomes of undergraduate research learning experiences.
Thank you. Morena.
Hi, I'm Marina. I'm a 3rd-year graduate student with Dr. Brenda Hall studying glacial geology.
Thank you. Emily.
Hi, I'm Emily Blackwood. I think I'm in my 3rd year of an interdisciplinary PhD. I'm working with Dan Sandwice and Rick Corey over in the VEMI lab to reconstruct archaeological sites using virtual reality.
Thank you. Megan.
Hi, I'm Megan Spoth. I'm going into my 2nd year of my PhD. I use lake cores to study the westerlies over the Holocene in the Falklands and now the Sierra Nevadas.
Thank you. Elise.
I'm a master's student in EES. I'm in Danielle Levesque's lab, and I'm using a predictive climate model to determine the effects of high ambient temperatures on northern flying squirrels.
Thank you. John.
My name is John Maurer. I am a master's student working with Dr. Seth Campbell. I focus on applying machine learning techniques to geophysical records, more specifically doing burn prediction modeling.
Thank you. Lygia.
Hello, everyone. My name is Lygia. I'm from Brazil, and this is my first year here. I'm working with Dr. Paul, and we're going to be looking at ice cores and water quality in Greenland.
Thank you. Mark. Oops, you're muted. Still muted. There you go.
Thanks. I'm a PhD student working with Peter Coons, doing physics-based modeling of complex fluid flows, which we're trying to apply mostly to river habitats.
Thank you. Ian.
Hi, I'm Ian Nesbitt. I'm working with Seth Campbell. I'm a third-year master's student working with Seth Campbell. I'm doing mostly GPR stuff, but it's pretty varied. So I do water research and glacial research. And I believe that's it.
Thank you. Andrea.
Hi, I'm Andrea. I'm a second-year master's student working with Jacqueline Gill on New England alpine plant community response to climate change.
Okay, and if you're a staff member, if you would raise your hand, the staff members are probably the most important people here. They're the ones who keep everything going in the financial, instrumentation, logistics side, et cetera. So we'll start with Betty, please. Betty Lee.
Hello to everybody. Good to see everybody, albeit virtually through Zoom. For those who I have yet to meet personally this semester, welcome to the Climate Change Institute. The assistant director of CCI and part of the admin team located on the third floor of Bryan Global Science Center. If you have any questions, please feel free to reach out to me and I'll get back to you as soon as possible. Hope everyone got a chance to enjoy some of this glorious sunshine today. Take care.
Thank you. Becky.
Hi, everyone. I'm Becky Adesi. I'm part of the admin staff up on the third floor, and I'm actually in my office 3 days a week now. So if you need me on campus, I'm here Tuesday through Thursday, 8 to 4:30. At my house the other 2 days, so I'll still answer emails. But I am here if you need anything, stop by or just shoot me an email and I can deal with it right here on campus.
Thank you. And thank you for organizing the icebreaker. Elena.
Hi, everybody. My name is Elena. I work in a tech laser ice core facility and also run ion chromatography labs. So if you have any question about those labs or about ice core freezer or melting system, come see me.
Thank you. And then there are two other people who aren't here on the technical, actually several others, three others, but you'll get to meet them at a later stage. Okay, I'm going to turn it over to Becky then, since you have the list of appearance and it got juggled around a little bit because some people have to leave early, some people are coming late. And we'll try to stick to roughly 2 minutes each, but if you have something really profound to say, feel free to go on. We're hoping to learn a little bit about the faculty, what your interests are. And for the graduate students, this is an opportunity for you to match a face with a name, perhaps find something that is relevant to what you do or what you might be interested in. So we're a pretty relaxed organization. Feel free to reach out to anybody in the Institute to ask questions of your graduate student colleagues and anybody on the faculty and staff. And we have a very, very diverse group of researchers and educators on the staff. So I'll turn it over to you, Becky. Who's number one on the list?
Kat Allen.
Okay.
If she's here.
Hi,
everyone. Here I am.
Thank you.
I have a couple slides to share if I may. Is that all right?
Yes,
Absolutely.
you should be able to share.
Great. Oop, hang on a second. Okay, sorry for the delay here. Let me try that one more time. How's that look? You see a nod or a thumbs up? Yes. Okay,
Great.
wonderful. Great. Well, it's nice to be to see so many familiar faces, and I'll just give you a very brief intro to my research program. I'm really interested in oceans and climate, past and present. It's pretty simple, and the oceans in Earth's climate system are really important. They transport a lot of heat and a lot of carbon around the planet from pole to pole and surface to deep ocean, and I'm interested in all of it. One of the things that I do in my research group is develop new tools for investigating the past ocean. I mean, in the absence of a time machine, the next best thing for me are geochemical proxies. So I develop tools here at UMaine to reconstruct past ocean temperature, past ocean pH, things like that. And I use microfossils. This beauty on the left here is an example of a microfossil that my group works with. And they're tiny, about the size of a grain of sand, but they hold a lot of paleo information. Then what we do is we take those tools and apply them to marine archives. We collect marine sediment cores, apply what we've learned, and then we assess the timing, rate, and magnitude of changes in Earth's past to gain insight into the mechanisms of global change. And as I said, I'm interested in how the whole planet on a global scale works. So our research areas span from right here in the Gulf of Maine down to the Southern Indian Ocean and the South Pacific. And we're really trying hard to understand the ocean's role in climate change, particularly in the late Pleistocene. But I'm also dipping my toe into the much earlier time periods now, maybe launching myself back into the Eocene. So we'll see how that goes. And this summer, just as a quick taste of what I've been up to most recently, I was thrilled to be on a research cruise this summer in the Gulf of Maine. We did a grand tour. Those white dots are where some of our study sites where we collected water and plankton and sediment cores. And the black dots are where we got long cores that went back as far as we can go in the Gulf of Maine. So I know it's a short, 2 minutes is not very long, but I just wanted to mention that I'm very lucky to work with a wonderful team of collaborators that include many Climate Change Institute folks, including Bonnie Newsome, Alice Kelly, Brenda Hall, Aaron Putnam, Carl Kreutz, and others. And I hope that list will continue to grow as I get to know more of you. And I also want to give a shout out to my students. Madeline Woods is a cooperating member also of the CCI. She's not able to be here today, but she's one of my grad students who went on that cruise, and Cassie Sturpey is another, and they're fabulous, and as are my undergrad students. So I do really encourage folks to get in touch if you're interested in analysis of marine carbonates or any other kind of carbonates, or if you're interested in any of our work. Thanks.
Okay, next up is Kate Ruskin.
Thanks, Becky. Can you see my slides?
Yep.
Okay, great, thank you. My name is Kate Ruskin. I'm faculty in Ecology and Environmental Sciences with a home unit in the School of Biology and Ecology. Thank you for having me. I recently moved to Bryant. The EES program is located here now. So I'm in 123 and Lisa Gardner, our administrative specialist, is in 111 with Linda. I'm a conservation ecologist. So I got involved in the field because I was interested in figuring out how ecosystems work, both because they're fascinating, complex adaptive systems, and because I care about conserving our ecosystems and global biodiversity in the face of environmental change. So when I first got involved with CCI as a PhD student here, I was studying birds in tidal marshes, trying to figure out how their populations were doing, their habitat relationships, and how we could protect their populations in the future. That work has extended to looking at sort of the whole ecosystem, including some different ecosystems. After I returned as faculty, I embarked upon a project in Acadia National Park using an ecosystem services framework, so quantifying the benefits that humans get from ecosystems for free to assess the impact of the new campground they put in on Kudik Peninsula in 2015. And that was my first foray into social science, where my research program has grown since then. So we surveyed visitors to estimate economic impact of that campground. More recently, I've been working on evaluating stakeholder perspectives on Acadia's freshwater resources. And then most recently, I've embarked upon some STEM education research. So both using the classroom as a living lab to study the students. For example, I'm working as part of the RLE program, the Research Learning Experience program, with my new PhD student, Holly, who introduced herself earlier, to figure out what aspects of experiential learning contribute to improving STEM outcomes like retention in the fields and learning over time. What got me excited about this STEM education branch of research was teaching my own field course in Acadia, which I've talked about before, and I'm going to give a quick plug because we're always looking for new active research projects. But this is where I take students to Acadia. In 48 hours, they go from finding out what group assignment they're in to collecting data in the field, coming back to the lab and analyzing it, and then presenting the results of their research to the public, all in the span of a weekend. I've been proud to integrate this class with active funded research projects, most recently my own stakeholder freshwater research project. But I invite anyone else who's got projects in Acadia and would like 20 semi-trained scientists to collect data for them to please contact me. And I'd love to get my students on your project. So that wraps it up. I hope to hear from you, and please don't hesitate to reach out. Thanks.
Thanks, Kate. Next is Dom Winsky.
All right, hi everyone. I can show a slide okay, here we go. So hi everyone, hopefully you can see the screen now. So my name is Dominic Winsky. I'm a research assistant professor here in the Climate Change Institute. So my work really focuses on understanding the physical climate system, past and present. So most of my work, it can be summarized in studying the interaction between global scale forcing, something like greenhouse gases or insulation, and how that interacts with regional systems and regional climate variability, which is of course what really matters to specific stakeholders, whether they're organisms or people living in a certain locality. So a lot of my work is between Alaska and the Yukon and sort of the North Pacific region. So I've studied past climate change in sort of the North Pacific basin, looking at changes in temperature, precipitation, and more recently, wildfire, and the interactions between all of these processes and what mechanisms drive them. I also work in the Southern Hemisphere, looking at sea ice and sea ice proxies, sea salt, and how that's recorded in ice cores and what it can teach us about the past marine environment. I think as scientists, we all have, a responsibility to take what we're learning about the climate system and then bringing that to actual citizens. So I've been quite involved in both the conservation and education communities in Washington County in eastern Maine, where I grew up. Basically using the knowledge from these ice cores and then applying that to actual solutions and climate mitigation and adaptation projects back home. So for the grad students, please let me know if any of these projects sound interesting, or if you just need help with time series analysis, model data sets, gridded climate outputs, please get in touch with me. I'd be happy to help. Thank you.
Thanks, Dom. Next up is Sean Burkle.
Hello, everyone. Bear with me for a moment while I get my screen shared. Okay. Can everyone see the full screen?
Nope, not seeing it, Sean.
Sorry about that. Let's see. Okay, I think this will work. How about that?
Yep, can see it now.
Right. Thank you.
Sean
There you go. Yeah, no matter how many times we do Zoom, sometimes we goof. Anyway, I'm Sean Burkle. Up until recently, I was on the research faculty with the Climate Change Institute, but as of September, I'm now have a joint position with CCI and also Cooperative Extension, and I'm the Maine State climatologist. And most of what I do relates to climate modeling, analysis, and data visualization. And I have both research interests and also the role that I do as state climatologist. So to just give you a brief overview, my research interests are primarily related to understanding climate teleconnections to Maine, in particular, linkages to the Arctic, North Atlantic, and Maine climate. Also large-scale climate variability. And increasingly, as I work more with colleagues in Cooperative Extension, impacts on Maine agriculture. And as many of you know, I've developed the website Climate Reanalyzer. That's a project I started back in 2012, I believe. And the project began as a means, Paul had asked me if there was a way that we could get climate reanalysis models, get easy access to them for mostly internally, so we could access the model outputs. And that set me on this path of putting more and more reanalysis models, climate models, weather forecast models into a framework where people could access the information both for research purposes, educational purposes, and then also there's some public access components to this as well. And likewise, as state climatologist, I've taken that sort of idea and I've been developing the Maine Climate Office website as an access point for Maine climate and weather data and information. I'm also serving on the scientific and technical subcommittee of the Maine Climate Council, and I'm affiliated with both the Arctic and also the One Health NRT programs that some of the students are involved in. And just to wrap up, as a state climatologist, I'm trying to build up the Maine Climate Office, and I'd like to involve faculty and students. This is meant to be a place to get data, but also additional resources as well. But if anyone who has questions about how to get data, where to access certain models, please feel free to reach out. And thank you.
Thank you, Sean. Next up is Chaw. Oh, sorry. Nope, my bad. Next up is Seth Campbell. I'm going out of order here. Sorry.
Okay, I assume people can see this. So I'm Seth Campbell. I am an assistant professor in the School of Earth and Climate Sciences and Climate Change Institute. And I also have a second hat as the director for the Juneau Icefield Research Program, which is a program that we brought to UMaine in 2018 when I started here in my assistant professor role with CCI. And my work primarily focuses on looking at ice and changes in ice across the planet. So that includes the Arctic and the Antarctic, it includes glaciers and ice sheets. And also I spend a fair amount of time looking at permafrost distribution across both regions and changes to that distribution. I work with a number of folks on paleoclimate and glacier reconstruction work. Several folks within CCI and Earth and Climate Sciences on that. So the figure in the upper right-hand side is a radar geophysics profile of a glacier in Canada. And that dashed dotted line that you see there is where they drilled an ice core in 2002. And as an example, we're working on another proposal to go back and drill there for a deeper ice core in future years. And a lot of what I do is taking physical observations in the field and trying to relate that to climate change via numerical models with other colleagues. Beyond that, as I mentioned, the Gene Icefield Research Program, there's plenty of room for student involvement in JERP. This year we had 10 undergraduate and graduate students on the ice field from Maine. We generally have up to 60 people on the ice field from around the world. Next year, it's likely we're going to have about 120 to 140 people on the ice field with some new programs that are ramping up. So if you're interested in learning more about the Gene Ice Field, you have the website there, and feel free to reach out to me. And that's it.
Thank you, Seth. Now up is Cha.
You're muted. Nobody's heard anything yet.
Well, thanks, Dan, for letting me know. I mean, the other people were not so kind, but sorry about that. I'm Sudarshan Chaudhary. I'm a computer scientist. I work on data management problems. Last year at this event, I gave a talk called What's Clogging Your Data Pipeline? And I think many of our data pipelines are still clogged, but I felt like I should give you some new title at least, even if the content is the same. And so this time I'm saying data preparation exposed. Last time I made a point of noting that the glamorous part of the data business these days anyway is stuff like machine learning and AI and so on. And that's all cool stuff, except that from a practical point of view, most of us, especially in this organization, I would think, don't really have to worry about it because there's lots of really good tools out there. And even though it would be nice, perhaps, if we understood those tools very deeply, we really don't need to. You can use it mostly as a black box and get some pretty decent results. The problem lies in the earlier stages of the pipeline, which is getting our data into a form that is usable by these tools. And so last year I said that's kind of a problem of data integration, and that's where all the action is. And I don't want to say I lied because that is the truth, but then thinking about it, I felt like I wasn't as honest as I could be, perhaps, because what happens is no one likes to talk about the unglamorous parts of the data business. And so when I said data integration, I wasn't lying, but the problem, the way I wasn't fully honest is that there's been a lot of work in data integration as well. And what I said earlier about machine learning and so on, to a lesser extent, also applies to data integration. And so the real action is not so much in the data integration, but in a very, very small part of data integration. So this sort of reminds me of those geological timescales, which I'm sure everybody here knows a lot better than me. So you just kind of focus it on this little narrow slice where all the action is. And that's what I wanted to bring to everyone's attention today. That's the data preparation part of it. And I think we all know what it means. We get the data in whatever form someone gives it to us, and we need to put it in a form that is actually usable by some tools. It's very unglamorous, it's very essential. And as I said, most people don't like to talk about it. It's just like some, oh, you know, I just kind of did it somehow. And yeah, let's talk about something more interesting. And so the problem I'm working on is there a better way to do it? And of course, if I'm asking the question, then the answer has got to be yes. And what are some ideas we can use? So at a high level, the idea is to use machine learning for the task of data preparation itself. So not machine learning after doing data preparation in some horrible way that no one wants to talk about, but instead using it to make the task of data preparation easier. So I think I'll stop here with an invitation to everyone to, please send me all your unwashed masses of data. And yeah, I forget all the other adjectives there, but it could be like the Statue of Liberty for data. So thank you, everyone. And I apologize, I'm going to have to leave a bit early.
Thank you. Next is George Denton.
Yeah, my name is George Denton. I'm in the CCI and also in the School for Earth and Climate Sciences. My interests have to do with southern, at the present time anyway, with Southern Hemisphere climate. And most of my effort has been into something we're calling Zealandia switch, which involves the interaction of the Southern Hemisphere westerlies with the megacontinent of Zealandia and Australia, and how this affects global climate. Because we have a feeling that it gives the orbital input into ice age climate around the globe, and the switches, these switches in the Southern Hemisphere affect the entire globe. I work with colleagues at Maine, at Arizona, and at GNS Science in New Zealand. We have a similar program in the southern part of South America. We've had a steady stream of students involved in these programs for many, many years, but that's come to a halt now because of COVID problems. New Zealand is locked off right now from the rest of the world. It's called the Hermit Kingdom. It's locked off by the military and by the police. They don't allow people to come and go unless they're New Zealand citizens and have made extensive arrangements for this. So I also involved heavily with the Coma Climate Foundation in Wisconsin, and that has funded a lot of our students over many of the years. We just finished a 4-day workshop online with that. And that's about it.
Thank you, George. Next is Dan Dixon.
Dan, you're still muted too.
Can you hear me now?
Yep.
Cool. Hi, I'm Dan Dixon. I've been involved with the CCI since 2000. I came here as a master's student, then stayed around at a PhD, then a postdoc, and now I'm involved as a research assistant professor. My research since being involved with the CCI has really focused on ice core chemistry, reconstructing past atmospheric conditions, and I've been involved in the collection, processing, interpretation, and publishing of ice core data ever since I arrived. I've been on 15 different expeditions to different places all around the world, ranging from the Antarctic to southern Patagonia, the New Zealand Southern Alps, the central Chilean Andes, the Olympic Peninsula, South Georgia, Yukon, and the Peruvian Andes. And I've really taken a shine to operating and maintaining and designing ice core drills. So I'm heavily invested in that at the moment. And my most recent venture into drill design involves a CCI thermal drill. And I'm excited because I just received some new thermal drill head bits, which we're going to test out soon. And so that's quite exciting. We're hoping this will give us the capacity to recover paleoclimate data from temperate glaciers and wet glaciers and possibly low elevation sites. So that should be good. I'm also, my second hat is as the Director of Sustainability for the UMaine campus. So I do a lot of work there in that respect as well. So I'm always available, so feel free to email me anytime, and I'd love to help out things and get involved with things. Nice to meet you all.
Thank you, Dan. Next up is Brenda Hall.
All right, let's get this. There we go. Hi, my name is Brenda Hall, and I'm in the Climate Change Institute and the School of Earth and Climate Sciences. I am interested in glacial and quaternary geology, and there'll be a series of slides which will cycle through here that show a number of the locations where I work and also some of the problems that I'm interested in the boxes that you can see here. Basically, I'm interested in climate change on a variety of timescales, ranging from really long-term, millions of years, to ice age cycles, to Holocene and millennial scale variability. My primary tools for doing that is glacial geomorphology, as well as using glaciers as recorders of climate. I also have used lake sediments, peat bogs, pretty much anything that will give a climate record. So you may have seen the dead seal on the first slide. I've used records of former seal colonies to reconstruct Holocene temperature changes in the Antarctic. So I also do a lot of chronologic work. Along with Aaron Putnam, I run the UMaine Cosmogenic Isotope Lab. So we have a fully functioning state-of-the-art lab, which is churning out dates at a fairly rapid pace. So if you have any cosmogenic dating interests, please let me know. I also do quite a bit of radiocarbon and U-series dates of lacustrine carbonates and corals. So I love interdisciplinary projects. So if any of this interests you, let me know. Thanks.
Thanks, Brenda. Next up is Daniel Hayes.
Hi, everybody. Good to meet you as well, because I am kind of the nutty new guy here. I only just took my CCI test in March. Oh, wait, you're not looking at my, yes, you are. Oh no, I'm that guy. Are you seeing my slides or my desktop?
No, we see your slide, Dan.
Oh, good, thank you. Like Sean said, it's not like we haven't done this a million times. Okay, so I took my test and I assume I passed because I get the emails now, so that's exciting. So I'm excited to join today. My name is Dan. I am actually over in Nutting Hall, a couple doors down from most of you. Don't be shy to stop by. We don't see many of you over here, so come on in. We have a couple. Met a couple of the grad students on the list in class, so that's good. I'm also the nominally director of the Wheatland Lab, which we do remote sensing and work with imagery and drone technology and other things with forest industry. My research topics, let's say in the realm of ecosystem ecology, forests, of course, and the climate change aspects of both the drivers and feedbacks of climate change and ecosystems. I work in natural and managed forests like here in Maine. I'm interested in the temperate boreal transition forests also here in Maine, as well as over and do work a lot with colleagues on the Canadian side. And to, as many in this group, also spend time in Alaska and Canada and other Arctic ecosystems looking at changes in permafrost landscapes and the consequences for carbon and climate there. And then the tools are primarily using remote sensing as kind of my main thing, doing a lot of forest modeling with LiDAR data, carbon budget accounting, so simple spreadsheet stuff, all the way to like super complex land surface modeling that go into Earth system models. So looking at it from all those different things. And the remote sensing part is I do, that's where the teaching happens for me. If you can call it teaching what I do, I try. But that's why I've met some of the grad students. I think Scott Braddock was on, and still is on. He was kind of the pioneer a few years ago. He came over and took the class that normally was just forestry and wildlife students from Nutting Hall. So that was great. It sort of made everybody else comfortable. It's like, well, Scott's cool, so if he's doing it, then they will too. So we've gotten a lot of students in the last couple of years from the Climate Change Institute, which is really fun. So keep that coming. Come over and look at INT 527 or other classes that we have over here that are relevant. And then just a quick list of some projects that are ongoing to get a flavor. There's working with everything from forest industry here in Maine to work on their using LiDAR for forest inventory, to doing the carbon budget accounting for the state of Maine to look at, for example, how much the forest uptake of carbon can offset fossil fuel emissions for their greenhouse gas reporting. And then a number of other carbon style projects that particularly using NASA assets from drones, airplanes, satellites, and looking at how we can use these data to keep track of our carbon monitoring and what our forests are doing in terms of their ability to mitigate the effects of climate change. And then a couple of ongoing experiments working in the Arctic and going back to Alaska someday when the COVIDs are over. So thank you.
Thank you. Next up is Shailene.
Hello, everyone. My name is Shailene Jain. I'm a faculty member in civil and environmental engineering. My research and teaching interests are in the water sustainability area, and especially in the context of climate variability and change. One aspect I'm especially interested in and how to translate this knowledge for infrastructure and design, water policy, rule making, and just a broad adaptation to climate change for infrastructure. I use generally historical and climate model data and statistical approaches to analyze those. Among my recent activities, I'm on the American Society of Civil Engineers and National Committee on Climate Adaptation, and we are updating and writing new manuals of practice for infrastructure design that actively integrate climate information. So the one I'm currently involved is on compound extremes, and so here examples of these would be the simultaneous occurrence of extreme rainfall and storms, surges on the coastline, and we currently do not have approaches to analyze and design. Outside of that, I'm interested in thinking about how water policy actively can and should integrate equity. And so that's a topic that one of my current graduate students is focusing on. Thank you, and welcome to all of the new students.
Thank you. Next is Peter Coons.
See if it works. I hope you can see that. I hope somebody will let me know before too long if they can't.
Loud and clear.
Good. Thank you. My name is Peter Coons. I'm with the school CCI, solid and good dynamic. I'm particularly interested in the multi-scale problem. That is the problem which Dom mentioned, and that is the effect that global scale behavior influences society and habit on sub-meter scales. So we have these scales which go from global oceanic scales, similar to the model which Nick Whiteman has put together on the left, and which I hope some of you have seen, which has a global model for wave fields and the effect of those waves on the coast. That was very local matter. That is, it's sometimes sub-meter. So that catches some of the things that we try to do. And in this particular case, it's associated with coastal erosion that may or may not have ice. The people that I work with have many different interests, and I appreciate very much having them as colleagues. This is from a proposal that we have with Brenda and George and a number of others, in which really looking at the effect of a global change in the Southern Hemisphere westerly pattern and how it affects the climates in the Antarctic climate particularly. And we take a normal mesh model from the Antarctic, a finite element model, and act upon it with a changing accumulation that's compatible with the modeled climate model, and then look at the change, and then look at the geology, and actually get people with any luck onto the Earth and take a look at some of the outcrops, and this looks to be like we good. In general, we look at a combination then of mesh methods and meshless methods to incorporate the very large and the very small scales that we're looking at. Some of those are ones we've looked at before. Examples that I really want to focus on are some of those of the people that I'm working with now, particularly the relationship between the flow patterns, whether they be water, air, or ice, and some of the habitat growth. And this happens to be a model of Mark Jordan's, and some of you again may have seen it before, but it's associated with an engineered log jam. And this is a 2D slice of some of that 3D flow captured by our particle methods. And we're interested in how it affects the salmon habitat, and not just the salmon habitat, but in detail. Increasingly, we're interested in how it affects things like the macro invertebrates, which I think I've seen, but I don't really know a great deal about. However, this particular picture here, we've got the large scale flow field and then the small scale flow field on something that Mark has just recently done. And fortunately, a nice little stonefly down here. And pointing out again that that when we look at any changing environmental flow at a large scale, then we're interested at the local scale. And the other problem that we have and are working on, particularly with Nick Whiteman, is looking at the problem of the atmosphere in a global way, and then how does it affect breathe it. The example that Nick's put together of an individual walking down a Bryant corridor, and the disturbance is shown here on the left. And we've taken the same physics and applied it. He's applied it, most of you go back. He's applied it to looking at other settings, indoor settings, such as commercial aircraft. In this particular example, has this poor individual sitting in the front with particles flying around him, and then puts the gas bra on, that is that overhead thing that people turn on when they get in. And the flow pattern is exceptionally different from what the commercial airlines tell you it is, and it's worthwhile trying to work this out as delta variant becomes more important. So we look at all different scales, and if anybody has any questions about applying any of these, give me a shout. I'm delighted to work with different groups. Thank you.
Thank you. Next is Andre.
Okay, I cannot start sharing until Peter will stop sharing.
Ha, you'll be lucky.
Thank you,
There you
Peter.
go.
Okay. I'll try to bring you down to earth in my short and ugly talk. So my name is Andrei Kerbotov, and I also would like to extend my welcome to new members of the Institute. And I work at the Climate Change Institute and also at School of Earth and Climate Sciences. My major media that I work with is ice cores. In this image on the bottom of the screen, you see the ice core, and the actual media that I work quite often with is the tephra layer. This little dark band right here, it's a visible tephra layer. But the irony is that I actually work with the invisible layers mainly. And I kind of summarize my research areas and by topics that seems like most relevant right now. So as I said, I work with volcanism and Earth, role of volcanism in Earth and climate system. And specifically what we're looking for these really big explosive eruptions. And so quite often they seem depositing this huge sulfate layers in ice cores. Sometimes these layers have tephra or these microscopic particles, sometimes they don't. And that's what we're trying to sort out. And we're trying to understand how it's all interacting with the Earth system and climate system. So I have these two projects in South Pole, and I work with Marty Yates on SEM-ADS system at the School of Earth and Climate Sciences. Chris Gerby sometimes helping us also, and he was a co-member in some early projects. With Dom and Winsky and Carl Kreutz, now we're looking for tephra in Denali core. We have really a good student who is doing it right now with us. Another kind of aspect of our work is this paleoclimate reconstructions from ice cores and blue ice areas. So Paul started this when he was in New Hampshire. He moved here, and this project where they were looking for blue ice areas actually flourished to the point that we actually found very old ice, oldest ice on Earth. And now we recently just got funded to look for this oldest ice exploration. And it's kind of will start it in the same blue ice areas. And the project itself will kind of migrate to the central part of East Antarctica, where the hope is to find the oldest ice for the US ice coring community. And most of these projects funded by NSF, but I also have this remarkable project with Harvard, and Paul Majewski is a PI in it. It's funded by Arcadia Foundation. And it's a Colli Nefetti, Swiss Alps. And it's basically a basic idea behind this, understand how climate in the past, as reconstructions from proxy that ice core data providing, could actually be used to understand better the role of the climate in the history, in the human history. So it's a remarkable project. We learn a lot. And next part that I'm kind of like always playing with, it's trying to play with technology and some tools. So recently I have this idea that we're trying to do with some people in Minnesota, where we're trying to cut ice cores with a laser. And the idea behind this is very simple. In industrial applications, they use a lot of lasers nowadays, and they're cutting things. But it's really not that simple when you're actually trying to do it in ice cores, because you have to deal with meltwater. As you understand, there's a lot of vapor in the system. And also what's not really simple here is this potential fractionation. So you kind of could impact your paleoclimate record. And this is one of the projects, but again, I have some unfunded collaboration with Chow, and I have some like interaction, and hopefully we're going to expand it a little bit more. We're just going to use this hyperspectral imaging. We're going to acquire this new camera and a core scanning system for Coldex. So I'm kind of looking for some new ideas and open to any collaborations. If you can have something in mind and we can work on something, to come to my office and send me email. It's easy to find me on the website. Thank you so much.
Thank you. Next up is Danielle.
Great, let me press all the buttons I need to do. Again, you'd think we'd all get used to this by now, but there we go. Can you see my slide? I didn't mean to start at the end. Okay. So going from ice cores to animals, I am an evo-physiologist. So I study mammals and temperature regulation and how to predict the impacts of climate change on these things. So some of the evolutionary physiology I do is looking at the impacts of past climate. And so some of the climate models that people are generating in CCI are always of interest to me for that. And then also to see how things are going to work. And in Maine, that means that we have a couple of species that are already on the move here, in particular the northern and southern flying squirrels. And so I had a bit of a fun grant this summer where with Sue Ishak and Pauline Kamath from the School of Food and Agriculture, where we're hopefully trying to look at kind of microbiome composition and diseases in small mammals on a gradient in Maine. And it just ended up being a really bummer of a year for trying to catch small mammals. And so didn't get much, but we did manage to make a little video with Ron Lissette in publicity that's going to go on the website for climate change in small mammals in Maine. And then part of the kind of theoretical work I've been doing lately is trying to figure out how we can predict the impacts of climate change on endotherms. It's very confusing. It's not as straightforward as it is with animals that can't produce their own heat. And so working through this sort of framework of how we take air temperature through to body temperature and then performance and then ultimately fitness. And then a lot of more detailed things on body temperature and how complicated it is. So here's a spread of all body temperature for all mammals. There's quite a lot of variability, but even within a single mammal, there's a lot of variability. So also dealing with time series in terms of body temperatures, and then trying to kind of figure out what we should be analyzing when we're comparing body temperature between different species. So here we have a tenrec, which is closer related to an elephant, and a tree shrew, which looks like a squirrel, but it's actually more like a primate. And so a new project that has nothing really to do with climate change that I've been working on is looking into the genomics of body temperature in mammals. So that's a kind of completely different direction. But more excitingly, I just got an NSF career grant that starts this year, and I'm hiring a PhD student. So if anybody knows anyone who wants to submit an application sort of this week, I'm going to start hiring. But it means over the next few years, I'm going to have a lot of interesting data on a bunch of really weird species, and ultimately, we're going to be using these data. Sean Burkle has a small component on the grant to help me build better mechanistic models for predicting responses of mammals, both in the tropics and out of the tropics, to climate change. So watch this space for what my students and I are going to be coming up with in the next little bit. And for the new students, I realize I just said all of that very quickly. I can speak slowly when I force myself to. I teach a graduate seminar on using these mechanistic models, or how to understand how animals and climate change work. And so it's every second fall. And so it'll be offered next year in the fall. If anybody's interested, you're welcome to get in touch with me. It's a 3-credit graduate seminar. And I think this next round, we're going to try to get a class paper out of it. So there we go.
Thank you. Next up is Paul.
Okay. Okay, my name is Paul Majewski. I'm the director of the Climate Change Institute, and I have academic affiliations with the School of Earth and Climate Sciences, School of Marine Sciences, School of Policy and International Affairs, the Business School, and the Law School. These red dots represent places where I have been involved in projects over my career. I've led more than 60 expeditions into some of the remotest parts of the planet, high elevation areas and in major mountain ranges such as the Himalayas, the Andes, more than 20,000 miles of surface traverses using everything from my feet to large vehicles across Antarctica and Greenland. And a variety of other things, most recently in excess of about 3,000 miles of sailing in a sailboat in the Southern Ocean. I've worked with many of the people who are involved in today's presentation, many others. Out of those more than 60 expeditions that I've led, 3 are particularly prominent because they were very large. One was the Greenland Ice Sheet Project 2. That's where we verified the fact that climate can change very quickly, faster than a political cycle. We also demonstrated, importantly, that the atmosphere is particularly critical in this, and in particular, the westerlies, the jet stream. I formulated and led a 21-nation program called the International Transantarctic Scientific Expedition. It went on for quite a few years, sort of still continues. We covered a tremendous amount of the Antarctic, demonstrated that in fact you couldn't just study one part of the Antarctic and know what was going on throughout it. And this was the beginning of really understanding that Antarctica was changing quickly. And in fact was not this remote place that was absolutely timeless. We also looked at a lot of the chemistry captured in the Antarctic ice sheet and found out that it is, while it is the cleanest place on the planet, it is not devoid of human activity. 2018, I was approached by National Geographic, with whom I'd never worked before, Rolex, to lead the Mount Everest expedition, large multidisciplinary international expedition that several people were involved in from our institute. And it resulted in several major findings, and basically we contributed a tremendous amount of information to the part of our planet that's above 5,000 meters. And we currently have, and it's first authored by Mario, a paper demonstrating that even the very highest glacier on the planet, more than 8,000 meters, is impacted by climate change. And Heather Clifford wrote a fantastic paper summarizing a lot of the chemistry in the area. So I've been involved in past, present, and particularly interested in future climate, obviously heavily involved in abrupt climate change. It's discovery, verification, and demonstration. It works through the atmosphere. Changes in the chemistry of the atmosphere, ranging toxic metals, in particular things like lead, impacts on past civilizations, how they collapsed as a consequence of natural climate change, as a message for how we may see dramatic change in the future. Become heavily involved in health, particularly air quality and pandemics, working on the program that Andre mentioned. We've worked on the Black Death, demonstrating its impact on society, and also the World War I H1N1 pandemic. Worked on with water resources, come out with large papers discussing the global distribution of water towers and their sensitivity to climate change. And working with Sean Burkle and many others, particularly interested in developing much better ways to understand future climate and its impacts through plausible scenario planning. My outreach activities are very, very broad. I'm involved in several boards, both in Maine, the United States, and internationally. These are research and other boards. Have co-authored with many of my students a large number of publications, many of which have been quite transformative scientifically, given invited talks all over the world, and I've appeared in the media hundreds of times, most notably CBS 60 Minutes and the Emmy Award-winning Years of Living Dangerously. Thank you. It's great to see all of you, and particularly the welcome the new students.
Thank you. All right, next up we have Nicholas Masinsky.
Oh, I think it's not going to allow me to share my slides. I had a system preference problem, but I'll just describe my work. My name is Nick Masinsky. I'm an assistant professor at the Political Science Department and the School for Policy and International Affairs. My work looks at the intersection of policy, global governance, and climate migration, specifically looking at how climate migration is governed within the UN. So I'm really interested in thinking about how new treaties or agreements coming out of the UN climate conferences will affect climate migration. And some of my past research has been about how the global governance of migration has expanded to cover climate migration in different ways. My future research and the stuff that I'm working on right now is trying to measure different amounts of foreign aid that's used to help climate migration. So I presented a couple weeks ago at CCI about a new data set that looks at different types of climate migration aid, targeting different things like desertification or climate adaptation or resilience that is focused on climate migration. And overall, my research tries to ask questions about how soft laws or policies affect climate migrants and what are the unintended consequences of aid, and thinking about how both policy and data from CCI can be used together to make good policy. I'm very interested in being part of CCI. Thank you.
Thank you. Next up is Bonnie.
Hello, everyone. Does that look okay?
Looks good.
Okay, great. It's good to be here. My name is Bonnie Newsome. I'm an assistant professor of anthropology and a faculty associate with the Climate Change Institute. I'm also an alum of the Climate Change Institute. I'm an Indigenous archaeologist, and my research centers on the past lifeways of Indigenous peoples living in Maine and the Canadian Maritimes. My research is inspired by several goals, 3 goals primarily: to understand the 12,000-year history of Indigenous occupation of Maine and the Canadian Maritimes, to humanize people living in Maine prior to European colonization, and to make archaeology a more equitable discipline by making space for Indigenous voices in archaeological practice and interpretation. I focus heavily on shell heap research, particularly coastal shell heap research here in Maine. These are important repositories of Indigenous heritage, and they're fragile cultural and historic places. They are generally human-generated accumulation of shell. There are roughly 2,000 known shell heaps along the coast of Maine, and most are actively eroding from sea level rise, increased storm intensity, and freeze-thaw cycles. And as they erode, we lose exceptional and varied data sets that record past lifeways and environments, things like flora, fauna, and material culture remains. We also know that these are places of heritage to Maine's Indigenous peoples, and there are 4 federally recognized tribes in Maine that I work very closely with in terms of not just shell heap research, but archaeological research in general. One project that I'm involved in with several students is Acadia National Park research on archaeology, climate change, and community. We are revisiting some archaeological sites in the park that were excavated actually by my advisor, Dave Sanger, in the 1970s, and we're revisiting those spaces in an effort to give gather information for tribal stakeholders. The park is interested in co-management of some of these archaeological spaces at Acadia, and one of the first steps is that we have to get the information out to the communities about what is actually there. And so these are some images from this past summer where I had Park Service personnel and some students accompany me to the Isle of Ho, which is one area where we're doing some research, as well as Fraser Point. We're examining both lithic and ceramics material culture, and we're reanalyzing them through an Indigenous lens. And so we're bringing in Indigenous language and Indigenous worldviews to our understandings of material culture, as well as some of the sites in Acadia. Another area where we're working is Holmes Point West, which is in Machias Bay. I offer a field school there every other year. And again, this one is, the site is eroding rapidly, and it's in the homeland of Indigenous peoples, namely the Passamaquoddy tribe. And we work very closely with the Passamaquoddies on offering this field school and generating and bringing information to the community about that work. current collaborations, I work very closely with Dr. Alice Kelly on the Maine Midden Minders Initiative, a citizen science initiative designed to monitor erosion at shell heaps in Maine. I'm working with Dr. Kat Allen and working on a project to radiocarbon date swordfish and associated terrestrial species so that we can get a more refined time period for when swordfish were on the coast of Maine. Working with Dr. Gill and her students on paleoecology and Wabanaki partnerships. We're also working with Brian Frederick at FIRST on analyzing ceramic residues from archaeological sites in Maine. And also one final project I have going is with a couple of colleagues, one Dr. Courtney Hoffman and Dr. Alexis Mycolaju. Sorry, I always mess up her name, but we are looking at sea mink DNA, and we do have sea mink at some of our sites here in Maine, as well as other extinct species like great auk. And so we're they're focusing on fur bearers for that project. Happy to talk to folks. Here's my email and my phone number. My office hours are Tuesdays 1 to 3 or by appointment, and I'm located in 124 South Stevens Hall. Thank you.
Thanks. Okay, next up is David Reedmiller.
Right, thank you. And thanks everyone for taking a minute. I just want to say that I am grateful to be a part of the CCI community. I am an external associate, but I lead the Climate Center at the Gulf of Maine Research Institute. So I am based down in Portland. So for anybody who's down here, happy to connect anytime in our waterfront lab. And for those that don't know, GMRI is about an 80-person nonprofit on the Portland waterfront. We have historically done a lot of work in fisheries science and fisheries management, but go beyond just the basic research component of it. We have a really strong community program that works with everyone from the vessel level fishermen throughout the seafood supply chain and the whole kind of fisheries management process to kind of understand the evolution and dynamics of commercial fisheries and the integrated ecology and communities that rely on them. We also have a really strong education program that brings in about 10,000 middle school students throughout the state into our interactive lab, which is behind these windows right here. It's really cool. If you haven't seen it before, definitely come on by. And we really teach students how to measure otolith rings and understand how the Gulf of Maine is evolving and why that matters to them. And really what has happened over the past several years, though, is that folks at GMRI recognized that climate considerations were really penetrating so much of the work that was going on. And so they wanted to launch this new climate center, which is why I came on board, you know, recognizing that climate change presents an existential threat to coastal communities as we know them, but also that it doesn't have to, and that we can actually leverage climate action from the local to the global level to make sure that coastal communities and working waterfronts throughout the Gulf of Maine can thrive in a warmer world. And the way we're doing that in the context of the Climate Center is by delivering climate services to coastal and marine stakeholders. And this is kind of a catch-all phrase, but you can think about it as sort of customized climate information for a variety of different purposes. And we start with sort of the foundational science, right? We've got really strong capacities in fisheries ecology, resource economics, and even learning sciences now. We're on the brink of bringing on board a sea level rise scientist who will help with high resolution projections of sea level rise throughout the coast to deal with stronger coastal storms and the wide tidal range that we experience here. And we're looking to build out a variety of other capacities in the years ahead that you can see denoted with those asterisks. And our intention is to bring that science into the hands of our engagement experts, really with a focus on both the municipal climate action and the business climate action piece of this, so they can get it in the hands of our stakeholders, like I said, ranging from the vessel level fishermen all the way through to our elected leaders, so they can sort of understand what the science is telling them about the climate risks they face and even some of the opportunities that are emerging as a result. And we can bring that sort of more nuanced understanding of the issues that they're grappling with back in-house to design customized solutions. And that can be in the wild harvest seafood supply chain, or in kind of the farmed, more aquaculture space, but also thinking more broadly about what are the other aspects that are inhibiting climate action in the region. Chief among them is the identification and mobilization of finance. And so we're certainly thinking of bringing on capacity in that space. And you can see a variety of other capacities that we're looking to bring on board as well. And the whole point of this, of course, is to serve our stakeholders, to do user-inspired science, user-driven science. And so that's exactly what we're going to do, is be sort of an end-to-end provider of climate services, translating knowledge into on-the-ground action. And so this is a very sweeping and ambitious vision for the Climate Center, but it's also, I think, hopefully something that many of you can see in your own work, and for grad students that will eventually be looking for employment in a couple of years. We are in the process of raising resources to fund the positions that you can see asterisked here. So please stay in touch. You can learn more at gmri.org/climate, and you can contact me there, and I'd be happy to talk anytime. Really appreciate the opportunity to talk to you today.
Thank you. Next up is Laura Rickard.
Hey, thank you. Let me just share my screen. All right, thank you for hanging in there. And actually, it was great to go after GMRI because we're going to have some connections here. So my name's Laura Rickard. I'm an assistant professor. Sorry, I'm an associate professor. I demoted myself. I'm an associate professor in the Department of Communication and Journalism. I'm also affiliated faculty at the Aquaculture Research Institute and the Mitchell Center for Sustainability Solutions. I am a social scientist. Chiefly, I study risk perception and risk communication, and related to that, how we manage and think about natural resources. So my tie-in to the Climate Change Institute has to do with perceptions of climate change and how these might relate to attitudes, behaviors, and so on. So the context that I tend to work in, obviously climate change. I do a lot of work in sustainable aquaculture, especially in Maine. I work in national parks and have done quite a bit there, both with respect to visitor safety, but also just thinking about how we communicate about ideas like wilderness and ideas like climate change in the context of a national park. I also think about severe weather and natural hazards like hurricanes and so forth. And I've worked in Maine, I've worked more broadly in the US, and I'm beginning to work a little bit more internationally. So as a social scientist, I definitely use a mixed method approach. I apply quantitative and qualitative methods. And in my world, that means I do a lot of survey work. I also do experiments. So instead of ice cores, I am inviting people to read things and look at visuals and think about how they're perceiving particular statements, whether it's shifting their attitudes a little bit or not. I do quite a bit of qualitative work, like in-depth interviews, ethnographic observation. I've spent a long time watching people in national parks, for instance, just seeing what they do, which can be both mundane and really intriguing. I work with lots of partners, and some of these are funding sources, and some of them are folks who've been really integral to getting my research into sort of applied context. So right now I work with Maine and California Sea Grant on a series of projects, but mainly some funded by NOAA on looking at sustainable aquaculture development in land-based situations. So like we're seeing in Maine. I've worked with the National Park Service, as I said, and the National Science Foundation. One I wanted to point out, which is a little bit newer and exciting to me, is something called the NPCC4. It's the New York City Panel on Climate Change, which is convening, and it's an independent advisory body that they synthesize scientific information on climate change. They advise city policymakers on resiliency. So I've been invited to sit in on the communication subcommittee in that body. I'm going to be working with someone from Cornell who's kind of leading up that charge. So I'm really excited to understanding how to apply a lot of the theory-based work that I do to this context. Oops. So in terms of teaching, I just wanted to point out to the students here that I teach two courses at the grad level, communication theory and risk communication. I've had CCI folks in the class in the past. Heather Clifford, I remember you and you were wonderful. And I also have a ton of NRT students in my classes right now in my risk communication class. 2/3 of my class is in either the One Health or the Conservation Science NRT. I'm also affiliated with the Conservation Science NRT. So I embrace interdisciplinarity. So please don't be afraid if you've never taken a social science course. We invite everyone. And I love teaching the class in that way with that variety of perspectives. And I think I just want to leave you with a couple examples because often I get asked like, what is risk communication? What is environmental communication? And it's not talking to trees or glaciers like it sounds, but you know, it's things like this. So whoops, this is a publication came out a couple years ago, but it's thinking about this concept of psychological distance. So if we make climate change appear closer, does it actually make us want to engage more with it? And, you know, we would say, not really sometimes, but the verdict is it's not really clear yet. And so some of the work that I do tries to dispel a lot of these myths that we often have around sort of what feels right. It feels right to say if we tell people it's happening now and it's bad, that will cause them to be concerned and act. I've done some work with hurricane risk perceptions and thinking about how people consider past experiences in storms and then how that might influence their behavioral choices later down the road. So this was a study that was funded by NOAA to look at Hurricane Sandy. So we were thinking about residents in the tri-state area, so in Connecticut, New Jersey, and New York, and how people who had actually lived through that storm attributed responsibility for what happened to them, and then you know, sort of what they would do in the future. And then finally, just for fun, and I know the last presentation mentioned aquaculture, but I think about the role of narrative. So this was a fun study where we actually worked with Barton Seaver, who's a seafood chef, and we had him telling a story about how he came to use sustainable aquaculture to source it in his restaurants, and looked at exposing people to different kinds of narratives or more traditional sort of didactic information, and seeing how that in turn influenced their information processing, their emotion, and then their support for sustainable aquaculture development. So that's all I have. I'd love to hear from you, and I'm over in Dunn Hall, way other end of campus, but if you get to the football field, you'll find me. So thank you so much.
Thank you. Next up is Jim Rosko.
Sorry, I'm having a bit of trouble getting this up onto the screen. Well, I'll just continue on anyway. I'm Paul Rosko, which is probably why everybody calls me Jim. I'm a professor emeritus of anthropology in the anthropology department and a cooperating professor of climate change in the Climate Change Institute. As a cultural anthropologist, I've spent about 2 years of my life living in New Guinea with a tribe there called the Anguru Boykan. More recently, I've expanded my studies of New Guinea out to include a cross-cultural archival study of many of the societies in New Guinea. New Guinea might seem an awful long way away, but it is a fantastic theatre for studying the workings of small-scale societies. These would be the kinds of societies that existed on Earth from the Paleolithic to the Holocene transition. And my particular interest in using data on those societies is to investigate how and why war evolved in humans. We're one of the very few species on the planet that actually do kill our conspecifics. I'm interested as well in how warfare can fundamentally influence the structure and nature of our society. I've used some of that research in my second research interest, which is modeling the human dimensions of climate change. One interest in particular recently, as I've been working on, is how the pursuit of status, that would be pursuit of dominance and prestige in human society, that the role of status in driving climate change, human greenhouse gas emissions. Quite a few societies have status pursuits that are not damaging to the planet. In Contact-era New Guinea, some societies, males achieved status by the number of heads they could take in headhunting expeditions. And whatever else you want to say about headhunting, that does have a very low, a very small carbon footprint compared to the way that we in our societies, the industrial societies of the world, pursue prestige and dominance and status, and that's through the consumption of material goods. And I've been particularly interested in why some societies pursue material goods for status and others pursue other avenues. Cindy Eisenhower, who's in the Climate Change, and I have just published a book on this subject, consumption, status, and sustainability. That's come out through Cambridge, so I'd urge you to rush out to your local bookstore and buy it before all the copies run out. Another interest I've had is using my data from New Guinea to try and model the vulnerability of different nations to apocalyptic responses to climate change. Some nations do seem to be particularly prone to taking the, or likely to take the signs of climate change, fires, rising waters, storms, and so on, as evidence of the apocalypse approaching, the end times, when we either get rhapsodied up into the Empyrean or we end up, as we anthropologists say, dead. So that's some of the things that I've been working on. Thanks very much.
Thank you. Next up is Dan Sandwice.
Okay, let's see if this works. Can you all see that? Somebody?
Yep.
Yep.
Okay, thank you. Well, hi, everybody. Welcome, new students. Oh, good
It's
to
not
see
full
you.
screen, Dan.
It's not full screen. Yeah.
No, nope.
Here, how's that? Is that
A
better?
little better.
Yeah.
It's better.
There you
That'll
go.
work.
Yeah, I was trying to use that. It doesn't matter. Anyway, as long as you can see it and you're not seeing the rest of my screen mostly. There we go. So I'm Dan Sandwice. I want to welcome all the new students, particularly. I'm a professor in the anthropology department and in the Climate Change Institute. I am also the resident punter in the Climate Change Institute, although I have to say that I'm alphabetically unfortunate because I come after Jim Rosko and I just can't slay like he does. It's really bad when he gets ahead of me.
Jeez.
What do I do? So I knew you'd appreciate that, Jim. So I'm an archaeologist and I do most of my research in South America, mainly in Peru. I work on climate and culture in ancient Peru on a variety of aspects. In particular, I work on El Nino, and those who speak Spanish will recognize this as primary evidence of El Nino on the coast of Peru. We took this picture on the beach of the northern, or actually the westernmost point of South America in 2006. I believe Alice and Joe Kelly were with me, so if they were here, they could testify that we really did find this evidence of El Nino. And I work on ancient maritime adaptations, how people use the ocean and what influence it had on the way they developed. And that ties in closely with our studies of coastal climate. In addition to the scientific research that I do, I'm very interested in intercontinental archaeological practice, and in particularly in how we can improve relations with our colleagues in Latin America, in the areas where I do my research. It's their countries, their people. We work there as their guests, and we need to do a better job of getting along with them and making sure that we have equitable relations with people in the places where we work. So I have a number of activities that do that. I won't go into details, but if you're interested, let me know in these issues. And then finally, I just wanted to mention a course that Kirk Mosh and I were involved in. It was an online seminar on Zoom last spring. Many students from the Institute colleagues from the Institute, colleagues from elsewhere on campus, and a lot of colleagues from elsewhere in the hemisphere, even a couple of students from elsewhere in the US, were involved looking at equity in archaeological practice, although it might, as it turned out, be more appropriate to call it inequity in archaeological practice. And what we might do about that, we're currently working on 2 papers coming out of this class. One is how we did it as a model for others who might want to replicate the course. Many of the senior people who were involved said they wish they'd had it as grad students, so that inspired us. And the other is an analytic paper on what we actually learned and can continue learning from looking at these issues. And finally, we're also putting up a resource page on the Society for American Archaeology's website of resources that we've gathered and continue to gather in doing this work. And these 3 efforts are all being led by excellent graduate students who were involved in this course and are now taking the lead in the products. Thank you.
Thank you. And next up is Rachel.
So I'm going to share my screen. All right, how are we doing with that?
Good.
Oh, okay. So hi, everybody. I'm Rachel Chapman. I'm an assistant professor of sustainable agriculture in the School of Food and Agriculture. And it's an honor and a privilege to be part of the CCI community. I only have 1 slide, but I'll talk to you for a couple minutes about what I do. So I am an interdisciplinary agroecologist, and I look primarily at climate change and agriculture and how we both respond to it and contribute to it, and hopefully in some capacity mitigate some of the greenhouse gases that are associated with food production and food systems. What that means is that I have a lab full of wonderful graduate students who are working in both social science and natural science domains. So those who are working in social science use approaches like surveys and interviews and focus groups, qualitative and quantitative approaches, a lot of mixed method studies going on, looking at perceptions of risk, knowledge of climate change, and other psychosocial factors that play into how we manage landscapes. And I should say that most of my work is in agriculture, but I also have some graduate students who are working in forestry, and that there's a lot of overlap and interesting synergies between those 2 management systems. So that's fun. One of the ways that we then bridge over into the natural science realm is I work with a community of growers, mostly mixed vegetable growers, but also some wild blueberry producers now that I'm in Maine, on specific climate adaptation approaches on farm, mostly related to water source development and water use efficiency. So I have some trials going in irrigation efficiency and looking at how we decide when to turn water on and off and what kind of effect that has on production and natural system effects like leaching through the root zone and nitrate contamination. I'm also working with partners at USGS and the EPA, evaluating some new well designs that have recently been patented by USGS. There's a shallow well design, which is basically a constructed aquifer that holds a lot of promise for being a way that small scale growers in our region can supplement their irrigation supply, especially during periods of drought. So I think that's my 2 minutes. Lots of stuff going on, always excited to talk to interested graduate students, especially those who are interested in working directly with the agricultural community. I will figure out how to stop sharing now.
Thank you. Next up is Kristen.
All right. Hello, thank you all for hanging in there until the bitter end. I'm Kristen Shield. I'm an assistant professor in the School of Earth and Climate Sciences and CCI. I'm also the coordinator for UMaine Arctic. So if you happen to really like the Arctic or Arctic impacts, please let me know if you're not on the mailing list and we'll get you on that for the seminars. By training, I'm a physical glaciologist. I focus on ice, ocean, or ice water interactions. To do this, I use a lot of in situ data and a lot of remote sensing data. So in my lab, we work on projects kind of all over the world, any place that is icy or has ice. Some of them are in the processes of getting finished up. So all those dark blue ones down in Antarctica and Greenland and up in Svalbard. We have some that are in the process, both undergrads and high school students actually, working on some projects in Patagonia and at Everest, and then we have a few that are just starting up. So one of them is this glacier ocean biology interaction project Sydney's working on as part of the SANA NRT. And then I also have an iceberg geometry and melt rate project that's about to kick off. And with that, I'll be bringing on a master's student and a postdoc. So both of them will be joining CCI hopefully in the near future. But obviously all those places are cold, so I couldn't go and do field work. But during the time of COVID, we actually were able to get one project off the ground. And this is one that I did with Alice Kelly. We were looking at coastal erosion along the coast of Maine. So we went to a bunch of sites. We flew the drone. We did some GPS surveys and collected a baseline survey that we were lucky enough to get funded again for the next year with Joe Kelly and Bonnie Newsome. And so we'll be able to resurvey some of these sites, create really detailed maps of them and see what our coasts are doing. So if you have any interest in any remote sensing or in situ measurements or combining them, feel free to reach out. That's me.
Thank you. Next is Greg.
Hi, everybody. Let me share here. Okay. Hello, my name is Greg Zarrow. I'm a faculty member in the anthropology department and in the Climate Change Institute. I'm an archaeologist, and I would say broadly my interests are really understanding the process of urbanization and landscape change. So even more broadly, I'm interested in landscape change and how we can view that through urban landscapes. I've worked previously in Peru, studying mostly agricultural landscapes and change over time, and some in Belize as well, with a stronger focus on urbanization. Over the last 5 to 7 years or so, I guess, I've been working with colleagues at the University of Zadar in coastal Croatia. And really, if I think about how we use the archaeological record, I'm really focused on how we can use that and the historic record to provide a better context for our present situation on this planet. So thinking about this over the course of the last 3,000 years, late Holocene processes across different continents. In Croatia, it's really focused on the last 3,000 years and the city of Zadar, which is in the Ravničko-Kotari region here. It's an area, one of the low-lying areas along coastal Croatia that has a long history of agriculture, animal husbandry, and seafaring activities. But of course, Zadar is a living city. So as an archaeologist, we look for proxy records, and we have been working at the site of Nadin Gradina here, which is next to the small village of Nadin, but this is a hill fort complex that has proven to have a really long record for us to examine changes in the relationship between people and their environment through time. So what we found here are just a couple of subplots in this broader sphere of urbanization and landscape change. We do have about a 1,500-year continuous record, more or less, from early Iron Age, so early first millennium BCE into about the middle of the first millennium CE. So we have about 1,500-year record. We have good C14 dates, a good ceramic sequence that's fairly datable, but we do have some spotty occupation later in the late Middle Ages, and even you'll see one C14 date up here represented comes from a mosque. that represents this kind of reemergence of the settlement in the late Middle Ages and kind of a battle back and forth. This is right on the frontier of Venetian and Ottoman polities. So we've done some recent work on looking at that engagement of the manifestation of empire in a rural hinterland using monumental architecture and the artifact record. And in this case, we identified the remains of a mosque, which is pretty destroyed predominantly by the war in the 1990s. But you can see on the image on the right up here on top is what one of these single unit Ottoman mosques looked like in the 15th and 16th centuries across the Balkans. Looking more directly at the ancient archaeological record, the fact that we have this 1500-year record that's fairly continuous means that we can start trying to understand the evolution of this urban landscape from its origins as an Iron Age Liburnian hill fort into its foundation as a Roman municipium. And we're really seeing some interesting continuities with respect to street design and layout, architecture. Really the face of Nadine as a Roman municipium is founded in the Iron Age. And that's a pretty interesting conclusion that we're working on publishing now. With respect to its wider landscape, some of the other interesting subplots is the emergence of the olive as a landscape changer, in a sense, that we do see it somewhat in the Iron Age record, but it really blows up in the early Roman era. So the impact of Roman imperialism on landscape change is another focal point that we're really interested in pursuing going forward. So we have our colleagues at the University of Zadar, a few at the University of Zagreb as well, looking at the faunal record, a doctoral student at the University of Chicago who's been working with the macrobotanical record. And hopefully at some point we have a tremendous wood charcoal record that we want to jump into as well, which will really help understand a landscape change across this period of urban development. So that's kind of what we're doing with right now. You can imagine we haven't had any field work in a couple of years, but we're kind of pivoting towards more of the material science side of the project now. Thank you.
Thank you. Next up is Katie Glover.
All right. So hopefully that works now. Good to see everyone. I'm Katie Glover, and I'm a research associate and instructor here for courses on ecology, on data science, and gender issues and climate change. I'm also currently coordinating efforts to create more online climate change curriculum with CCI and the Division of Lifelong Learning. So my research focuses on past ecosystem change, especially climate, vegetation, and fire interactions in Mediterranean ecosystems. I've worked with pollen data at both individual sites and, as this figure shows, to study regional shifts in vegetation communities. So this is actually from a forthcoming review of pollen records from the West Coast, where we used PCA to compare vegetation communities during past temperature extremes with modern communities. And that informed where we can expect communities that are more either resilient or vulnerable to future change. And then zooming in on Southern California, I've been part of the La Brea Tar Pits Museum and Food Webs project. And my role in that has been to do some vegetation modeling to look at these interactions in the past. And this summer I was supported by a summer faculty research grant to do some modeling work on vegetation change at this location. So I used the process-based model LPJ-GUESS. I test the role of wildfire and its interactions with vegetation and climate. I could show some of our preliminary results. Model runs from about 50 to 30,000 years ago. So right in marine isotope stage 3, show that we do have these major changes in vegetation composition, which is kind of exciting. So in the yellow here, this oak functional type really shows this expansion of woodlands from previously pine and juniper, like a real conifer dominated woodland. So for about 14,000 years, we see this oak woodland expansion. And then it reverts back again to this community, at least in terms of the individuals that we find on the landscape. And then we're also interested in primary productivity that comes from these plants, because that supports not only collaborators that are doing some food web modeling, but a lot of the exciting megafauna and mega herbivores and the Ice Age community that was there.
as part of the tar pits. And running a fire module this summer, I was able to see pine and shrub gets pretty suppressed in favor of the expansion of grasslands. We again still see oaks as part of that community too. And not shown here, but overall just a lot lower total biomass from having fire on this landscape, which are results we would have expected for Mediterranean ecosystems. But it's nice to see that verified with the modeling, and this is the first of its kind for this time period. So last year's icebreaker, I finished with kind of partnerships and outreach I was working on. And I'd like to speak a little bit now about ones that I'm working on here at Maine. So I'll give a quick overview. Since last spring, I have been meeting with Division of Lifelong Learning about adding an online version of CCI's graduate certificate in interdisciplinary studies. So we are currently working on a couple new elective courses as part of this, including one that would be on contemporary biodiversity issues, and then a summer workshop for educators as well. I've gotten a lot of interest in that workshop, both from CCI students and faculty, places like Gulf of Maine Research Institute, what else? Kennebunkport Climate Initiative. There's just been this explosion of initiatives for climate change education in the state of Maine, it seems. So folks who have expressed interest on being in a committee to help with this workshop design, I do expect we can get together in mid-October. And we're ready to send out a survey on just like themes, topics, availability for educators to help start designing that workshop. If you're interested in joining us, please do reach out and contact me. I definitely want to leverage your expertise and your network to get the word out about this. And additionally, if you're interested in any kind of process-based modeling that's adaptable to different time and spatial scales for a project, please reach out. Thank you.
Thank you. And to follow her, we have Molly.
Hi, everybody. Can you see my screen okay? Can you see my screen?
Yes.
Oh, okay. So I'm Molly Schaffler. I'm affiliated with the Climate Change Institute and the School of Earth and Climate Sciences, and I'm also do some work with the Center for Research in STEM Education. I'm based in Northport, and my big interest right now is helping K through 12 teachers have access to information for teaching about climate and climate change. So I'm just going to call your attention to this project we worked on in the spring. The state science education office made a call out for materials to help K-12 teachers teach about climate. And a committee of us got together and put together a page on the Institute website that is education resources. So just walking you through to get there, click on Climate Matters. And at the bottom of the list is Climate Education Resources. And this page, it's worth taking a look at. We've just put together some a synthesis and overview, some access to PDFs that have been published by different people in the Institute. Ice core perspectives. These are, this is a website, the Climate Reanalyzer, some climate data tools, the Maine Climate Office links, and all of these are, we've tied them loosely to the next generation science standards. So to help teachers get a sense of what grade and what topics they might be useful for. Some of the climate models that students could use, and then an extensive video library. We have actually 2 new videos that were just posted recently, one by Joe Kelly and one by Cindy Eisenhower. And this series is from the National Geographic Mount Everest expedition that Paul mentioned in 2019. So lots of great videos from that, which are useful in the classroom. And then a series of videos from some of Brenda's work at Reedy Glacier in Antarctica. And I think this was Bess Kaufman has a video, and Carl. So a lot of material here. These are the two new videos, Joe's and Cindy's. So I wanted to show this to you just because if some of you are doing a research project that you think would have be of interest to K-12 students, middle, high school, even elementary students, get in touch with me or Sean or Katie or Paul or Betty and let us know, and we can figure out a way to help you make a short video, or if you have other materials that you think would be useful for teachers and students. I'd be happy to work with you on those materials and tailor them so that they're appropriate for the classroom. So this outreach to K-12 teachers and students is really important now, and there's a big push for it in the schools. So I'd be happy to brainstorm with any of you for ideas about that. Thanks.
Thank you. Next up is Ivan.
Good evening, everyone. It's been great to take a tour of all the activities ongoing. Let's see if I can do this. Can you see a slide? Good. So I'm Ivan Fernandez. I'm a soil scientist, biogeochemist in the School of Forest Resources, the Climate Change Institute, and the School of Food and Agriculture. And my interests are in a sort of a wide range of biogeochemical phenomena in ecosystems. I usually work at the ecosystem level, although I sort of dyed in the wool, as they may say, soil scientist. And I'll very quickly here, if this works. There we go. So a lot of my work has been involved with multidisciplinary ecosystem scale experiments, a lot of ecosystem manipulation experiments over my career. These are plots of stream chemistry for sulfate on the left and nitrate on the right from one of those paired watershed experiments that we've run for 3 decades, treating one watershed, a big acid rain experiment, climate change experiment. One watershed we flew a helicopter every 2 months and treated with nitrogen and sulfur, and the other was the reference. We've also had watersheds in Acadia and the big woods of northern Maine and other intensive study sites. Incidentally, those traces there that you see, particularly the one going down on the left, which is declining sulfates, a great example of how science-informed policy, namely the Clean Air Act reauthorization of 1990, leads to policy that produces results. And we've seen dramatic improvements in some aspects of certainly air quality as a result of it. And we see it in ecosystems. And that's an exciting thing to track and to demonstrate. I've done a lot of work on carbon over my whole career, but in the recent past, there's been a tremendous emphasis on essentially all things carbon. The left-hand figure there is a cartoon from the state carbon budget, an initial state carbon budget that drove a lot of the policy discussions over the last 18 months. Dan Hayes mentioned that in his list of tasks, and Dan worked with Dan and others as a group to do that. And we're working ongoing with state agencies as well as university folks to continue the work to define the evolving carbon budget for the state of Maine. The plot on the right that I realize you can't see, it's just a bunch of bar graphs, but it's an effort that was funded by the U.S. Climate Alliance to evaluate alternative management practices to sequester carbon in one part of the panel is agriculture and the other part of the panel is in forests. And it also is anchored in an analysis of the the price of carbon and how that drives the degree of sequestration that's achieved. And then finally, I do a lot with science and policy linkages, some with EPA, a lot now with state activities, the Maine Climate Council, the 39-member council in the state of Maine that was established in 2019. I'm a member of that. And as are a number of other people in the Institute involved with various aspects of the work. All those little circles are different subcommittees and working groups that support ongoing the work of the council. I co-chair the Science and Technical Subcommittee, and as Sean mentioned, serve with him on that. And I'm on the Natural Working Lands Working Group. And so a huge amount of activity going on in Maine in the recent couple of years, with more to come. Very active legislative session this year. You'll be hearing more about that. If you're interested in the work of the council and some of the state involvement, certainly, or any of it, please get in touch. So thanks.
Thank you. Next we have Carl.
You guys see that?
Yep.
Okay, thanks. Thanks, Becky. Hey, everybody. My name's Carl Kreutz. I've got a few hats that I wear here. I'm a professor in the Climate Change Institute. I'm also the director of the School of Earth and Climate Sciences, and I serve as CCI's graduate coordinator. So for you grad students who are particularly those who are in the CCI master's program, I know who you are, you know who I am, and I've got to sign a whole bunch of forms for you at the end of your time here, so we'll know each other well. For all other CCI graduate students, I'm here certainly as a resource if you ever need me, so feel free to reach out if there's any way I can help you. I'm an earth scientist who uses geochemical tools to study the climate system. That's generally how I describe myself. I've had the good fortune to work around the world, developing lots of different paleoclimate proxies, mostly in the ice core record, much of which you've heard about already. So I thought I'd give you just very quickly a local example that sort of is typical of the approach that we take in different parts of the world. But this one is here in the northeastern US. So what I've got here is a figure from a paper that just came out in Nature Climate Change, looking at both, well, temperature trends in the northeastern US, both surface air temperature trends, which is in the lower left, and sea surface temperature trends in the lower right. Now, much of this is kind of familiar to us. We know it's warming. Certainly land temperatures are warming, and we have all heard about the Gulf of Maine warming that's been occurring for some time. But nobody's really tried to pair these up and try to look at the relationships between the two. It's a great paper. I'd encourage you to check it out. But what I'm going to focus on is the sea surface temperature trends in the Gulf of Maine. There's a hypothesis that much of this warming has been due to changes in the Gulf Stream, or the Atlantic meridional overturning circulation, so weakening of AMOC. So our approach to kind of testing that hypothesis is to use some of these very high resolution paleoclimate records that can be developed. And so what I'm showing here is work from Nina Whitney, who was a master's degree student here in CCI. She's now down at Woods Hole Oceanographic Institute as a NOAA climate and global change postdoc. And Nina, along with Al Wanamaker, another one of our alumni, have done a lot of work on this, taking ocean quahogs, which you see in the left side there, collecting these out in the Gulf of Maine, stitching them together. These things live for 100 or 100 plus years. You can stitch them together like we do in tree ring records. And on the right are all the different geochemical proxies that we developed from these records, along with some state-of-the-art general circulation model output and instrumental data. And the point here is that this approach of combining novel geochemical proxies with GCMs and instrumental data allows you to sort of probe some of these ideas of what's going on in the climate system. So in this case, I won't go into all the details here, but we can see that we do believe that the AMOC has been changing. And began changing in the early 1900s, leading to this warming in the Gulf of Maine. But the context here is that prior to that, you can see that the temperatures were actually cooling in the Gulf of Maine over the past several hundred years. So we work with lots of other people on this. I'll circle all the way back to Kat Allen's talk at the very beginning, her work in the Gulf of Maine to put this kind of stuff into a much longer context. So I'll stop there. Thanks.
Thank you. Our last speaker tonight is Kylie Daly, but he couldn't be here because he's teaching a class. So I will be running a video that he sent me. So if you hold on just a minute, I'll get it up and going.
Hi, everyone. I'm sorry I couldn't be with you in real time. The timing of this session overlaps with the course that I'm teaching, so you get this pre-recorded video instead. For those that I haven't had a chance to meet yet, my name is Kylie Daly. I am an associate at the Climate Change Institute, as well as an instructor with the Ecology and Environmental Science program. I have a background in environmental studies and public health, and I do just have a single slide I'll share to tell you a little bit more about my research interests. So I study socio-ecological systems and health. So what that means is that messy middle area where humans and the environment interact, and in particular, the health outcomes of those interactions. So more and more that relates to climate change and health outcomes. In particular, I'm interested in water and sanitation related health outcomes. So that includes things like water quality impacts, waterborne disease, and equitable access to water. Population-wise, I do a lot of work with rural, indigenous, and/or Arctic communities who tend to experience higher climate health burdens. A lot of my research involves risk assessment and epidemiology-based methods, often incorporating participatory elements. And so what that means is making sure that the people, these communities and populations that I mentioned who are affected by these health issues are reflected in the research process and a part of coming up with the solutions. So I think I'm just about at my time. So that is all for me right now. Thanks for listening, and I look forward to getting a chance to see you around.
Okay, thank you. Well, that was a whirlwind tour of not just the Climate Change Institute, but many associated units in our university, and a whirlwind tour of climate change. Also, remember, we have our Bourne's event in the spring. That's where we're really looking forward to hearing from all of the graduate students and some of the faculty who would like to speak. In addition, this spring, we will be celebrating the 50th anniversary of the Climate Change Institute, formerly called the Institute for Quaternary Studies, making us the, or at least one of the oldest multidisciplinary climate research units in the world. So thank you for participating. Thank you for your patience during the evening. We didn't take a break just because there was so much to go through. Maybe it was lucky that the other third of the Institute didn't come. We'd be here for a long time, but thanks and have a great evening.